All right, guys, let's begin our revision. And most importantly, looking at motion. All right, everything Newton's. This is very important because we would find it again in grade 12. So it's important that we take this very, very seriously. All right, so there was a question that you guys were doing, and let's look at it together. Two boxes P and Q resting on a rough. Okay, guys, the word rough tells me there is friction. So I'm going to underline my keywords. On a rough horizontal surface tells me there's normal. Are connected by a light inextensible string. String tells me there is tension. The boxes have masses 5 kg. Masses tells me of the weight, 5 kg and 2 kg respectively. A constant force F acting at an angle of 30 to the horizontal is applied. That gives me applied force. But the applied force is only on the 5 kg as shown in the diagram below. The two boxes now move to the right at a constant speed. Guys, when the object moves at constant speed, what do we know? Acceleration equals to what? 0. All right. Now, state Newton's first law of motion in words. An object will remain at rest or continue in uniform motion unless acted upon by an external force. An object, now those laws should be at your beck and call, all right? An object will remain at rest or continue in uniform motion unless acted upon by an external. So I'm just going to leave that. Point 2, a free body diagram on Q. What do we have? We have that. What forces do we have? Let's see, what force do you have? We have what? Normal. What other force? Gravitational force. Tension. The object is being pulled to the right. There we go. We have gravity, the force of gravity. We have here tension. We have here friction, which is by the way, and that is normal. You get your 4 marks. Block P experiences a constant frictional force of 5 newtons and box Q 3 newtons. Calculate the magnitude of F. Now, since the examiner wants me to calculate F, first thing is to draw the free body diagram as quickly as possible for F. Guys, once you draw your free body diagram, physics becomes very easy. You just enjoy flowing. So let's quickly draw the free body diagram of P. What do we know? Normal, gravity, there's an applied force, we have tension, and we have what? Friction. Fk, F, normal, and Fg. And we know that once we have what? An inclined force, what do? We have to resolve. So can we redraw our free body diagram very quickly? Because we're not going to work with that. We're going to work with this, that. So there'll be 2 forces actually pointing upwards. Fy and the normal force. We still have our tension this way. We still have our Fg. So what do we have? Fg, Fx, normal, Fy, Fk, and tension. The object is moving to the right. So let's keep right as positive. So this is going to be positive. The question is, what is Fx? Guys, we use our trig ratio to do that. That's our F. All right, Fx and Fy. So this is Fy, this is Fx, and this is theta. That's F. If you remember, I said the one that is opposite the angle, we should always use what? Sine. So Fy will be F sine theta, and fx will be f cos theta. Now that we know that f net is equal to ma, what do we have? Fx plus negative what? Friction plus negative tension would be equal to ma. Do we know fx? No, but we know it is f cos theta. Do we know the angle? 30. F cos 30. The friction on this one is 5. But we have a problem. We don't know the tension. Do we know the mass? Also 5. Now, what's the acceleration? 0. Why 0? Constant what? Velocity. So, guys, we are stuck, kind of. F cos 30 minus 5 equals to t. We are stuck. So we've got to go to the second object and try to find out if we can get tension there. Second object, we had how many forces acting again? So we say F net will be equal to what? Ma. If we choose the right again as positive, there are only two forces that we're going to use: tension and friction. Tension is to the right. So tension plus negative friction would be equal to what? Ma. T minus. What's the friction here? 3. Beautiful. Equals to what? 2 multiplied by 0. All right, so T equals to what? 3. Oh, lovely. Can we then bring it back? F cos 30 minus 5 equals to 3. F cos 30 will be equal to 8. What is F? 8 over cos 30. What's your answer now? 9 comma? That means we're using 2. All right. Guys, and that is it. That is it. Did it make sense now? Part 2, did it make sense? Amira? Paul? All right. Okay, securely, are we good? Lovely. So at constant velocity, acceleration equals to 0. Now, the next question has to do with application. I'll give you 3 minutes, or let's make it 4, because you have to read and apply. It's a continuation. Continuation. Don't like the look of this. It's just a graph. Try. All right. The string connecting P and Q suddenly breaks after 3 seconds while force F is still being applied. Let us draw the velocity time graph for the motion of P and Q before and after the string breaks as shown. Okay. Write down the time at which the string breaks. What's the time? That's 3. That's very easy there. All right. It's too easy, so you're gonna doubt it. 3 seconds. Thank you, Naseeba. At least Naseeba is not doubted. Which portion X, Y, or Z of the graph represent the motion of box X after the string breaks? What happens when the string breaks? That's why they ask us to actually state Newton's first law. The object is still going to continue. Is that okay? All right, let's check the diagram just to make sure. The string breaks. The string connecting P and Q breaks. I have a breakage here while this one is still there. What's going to happen to object Q? It's going to keep moving, but the speed will start what? Decreasing because there's no more applied. Lamina says, which portion X, Y, or Z of the graph represent the motion of box X? Why? Why? Because when the string breaks, all right, so the answer will be why. When the string breaks, the only force acting what? Friction. Q will be. What happens if the only force acting is friction? It decreases the speed. Okay? Therefore, the speed does what? The information in the graph to support your answer. It was first moving at 2 meters per second. And then what happens? When the string breaks, the only force acting on Q will be friction. And friction is cannot be X. X will be the one for what? For P. Then applied force. So this one would be for P, and this one would be for Q. The acceleration would increase, but Q's acceleration would what? D. You can add it that Q deceler. Because the net force is now acting backwards. It is now, that's the net force. That force is, the only force is what? Friction. Wasn't that bad? Okay. Just needed to interpret. Guys, are we okay? Let me know. Are we okay? Everybody okay? Thank you, part 2. Lovely. Let's see. No, I don't want this one. Yeah. Let's see some. One is connected, but let's quickly walk to 2, 3, and first. 8 minutes, 8 marks. Let's give you 6 minutes. 7 for you to be able to interpret. F equals to VI. Good. Are you happy now? X equals to VI delta T. Right? And delta X equals to VF plus VI. Okay, let's give you 6. Let's start counting again. guys. Yes, talk to me. Did you deal with it or it dealt with you? Which one? Okay, you got answers. Okay. Never, it dealt with you. Shame, man. Now you are sicker. Why is Taiba laughing? Taiba, did it deal with you? Shame. Sorry, Nusaiba. Come, guys, talk to me. So that I want to get the response so we can look at it together. Please send me your responses. Block P of unknown mass is placed on a rough surface. Rough means friction, right? It is connected to a second block of mass 3 kg by a light inextensible string, passing over a light frictionless pulley as shown. Initially, the system of mass is held stationary with the 3 kg block, 0.5 meters above the ground. When the system is released, when the system is released, the 3 kg moves vertically downwards and strikes the ground after 3 seconds. Define the term acceleration. What's your definition? Yes, Nasia, talk to me. Acceleration is the rate of change of velocity. Please let's write that definition down. The rate of change of velocity. Now calculate the magnitude of the acceleration of the 3 kg block using equations of motion. What do we know? That's what's going to define the equation that we're going to use. What do we know? The initial velocity is 0. Delta y, 0.5. Why am I using delta y? Because it's moving vertically downwards, right? What else do we know? Have it. We have time. What are we looking for? We're looking for A. Which one do you think we should use? Definitely the first one is out. We could use the second one. No, second one is also out because we don't have the final velocity. I think the third one will just be appropriate. So delta y equals to VI delta t plus 1 over 2 A delta t squared. What do we have here? 0.5, 0 multiplied by 3 plus 1 over 2a and 3 squared. What's your answer? 1 over 9. 1 over 9. And what's that in decimal? 0.11 meters per second squared. I'm sure we all got that one. Calculate the tension in the string. Let's see. Now that we know the acceleration, can we just simply use F net equals to ma? This is combining motion and Newton's law together. F net equals to ma. Let's see. Let's use the 3 kg. What forces are acting on the 3 kg? Gravity and tension. Gravity going down, right? But tension going where? Up. Let's choose downward as positive because that's the motion. So what are we going to have? Fg minus tension equals to what? Ma. What is Fg, by the way? Mg minus T. What's the mass? 3. What is G? 9,8 minus T. What is M again? What is our A? 0,11. Please get me an answer for T. Remember, this is going to be what? 29,4 minus T will be 0,33. So what do? We can switch sides. T then becomes 29,4 minus 0,33. What would that give you? 29, 0.07 newtons. All right. Did it make sense, guys? This is how we get work done. So the idea is about writing what you have and interpreting according to the formulas. Physics plastic side I, but physics is just, it's simple once you, the problem is we read a lot and we don't write the things down. Once you learn to cultivate that habit, as you read, write down. As you read, write down. Extract the information, you'll be fine. Okay, there we go. The magnitude of the kinetic friction experienced by P is 24 newtons. Please just write friction equals to 24 so I can go back to the question. Friction is 27 rather. We are supposed to draw a free body diagram on P. Just quickly write down the question. Free body diagram on P, and we are supposed to find what? The mass of P. So when I go to the question, we stay there. Friction is 27, free body diagram, and the mass. So here's the question again, and I'll give you, how many marks was that question? Basically, we are only calculating mass. So let me give you 5 minutes. 5. Once you're done, please let me know. Don't wait for the 5 minutes. Once you're done, just say done, done, done. If all of us are done, we can then walk through, even before the 5 minutes elapse. Huh? Yes, the object is in motion. Hi, hello, everybody. Were we able to? The free body diagram on P, I think that's quite straightforward. How many forces did you draw? Normal, gravity, tension, and friction. I mean, that's usually, that's a very basic one. Calculate the mass of the block. I don't think it's difficult though, once you have your free body diagram. Have that as our free body. And but we know that F net is equal to what? MA. Can we use that? Because we know the friction is 27. So can we say T plus negative friction? Right. Do we know the tension? What is the tension? Yeah, make life easy. 29,07 minus 27 m. What is the acceleration? We got that. 0, comma. Oh, easy. Guys, I thought this question was more. What is the mass? 18,82 kilograms. Is that what you all got? Please confirm for me. Am I giving you easy questions, man? Okay, awesome. Guys, let's see if there's taste here. Okay, yeah, that looks like an helicopter. Yeah, this looks 8 minutes or 7, so we can finish. Guys, please talk to me. You guys did not talk to me earlier on the other question. This one, you should please talk to me. Are we done? Please, guys, I'm not going to do anything until I hear from you, I promise. Still busy. Thank you, Naseba. Gogo, Sikulile, please. Sitle, talk to me. Taiba, you guys are too quiet for my liking. All right, at least you have an answer. That you're not sure it's another thing, but I need an answer. Mara, almost done. I know you're busy eating. That's why you're not finishing. Yeah, I promise you, if I can come to your house and there's food, that's why that child is not finishing. Sitle, Gogo, please talk to me. Paul, talk to me. Angela, all right, in 2 minutes we should be looking at it together. All right, you got the same answer as Taiba. Lovely. Yeah, what's your answer? One, one, two, three. All right, these guys have 111,61 as the mass. What did you get for 4.2? 1, 2, 3. Okay, let's see. A rescue helicopter is lifting two people upward, as shown in the diagram below. The tension in the cable is 1205,4 newtons, while the helicopter ascends at constant speed. Remember, we spoke about that word constant speed earlier on today. Constant speed, acceleration is equal to what? Zero. Guys, I'm sure Newton's second law is at the back of your, calculator. Right? That one you should know. When a net force acts on an object, the object will accelerate the net force with an acceleration that is what? Direct. Calculate the combined mass of the two people. What do we know, guys? Quickly. What do we know? If we were to draw a free body, which will assist us, what are we going to say? They have been pulled up by tension. Have a weight. Fg and tension. Mind you, A is equal to what? 0. Upward as positive because they are moving up, down. So T plus negative what? Fg equals to MA. Do we know the tension? 1205,4 minus M times 9,8 equals to what? 0. So 9,8 M equals to 1205,4. Do you want to confirm? 1, 2, 3. How did you guys get 1, 1, 1? The helicopter now starts to accelerate upward at 2,25. Calculate the tension in the cable. Already now we know the mass. Know the mass. Can we still use F net equals to MA? Now we don't know the tension. Minus 1, 2, 3 multiplied by what? 9,8. 1, 2, 3 for acceleration. 2,25. Right. So we just multiply that and move it over to the right hand side. Check with my calculator to make sure. 1, 2, 3 times 2 plus 1, 2, 3 1482,15. Newtons. Okay. Guys, please talk to me. Guys, this is how simple it can look. And this is how simple it should be done. Why did you guys get 116 though? I don't know. I wish I could see what you did. Taiba, do you want to please send me a picture? I want to see 111 came from. But the 111,16 so that we fix whatever error that is there. Right. So in our next session, we would look at universal gravitation. Okay, and electrostatics. That we do all of those at once in one session. Your timetables with me? Yes. Let me see. Oh, you saw your error. Let me see what Taiba did here quickly. Times 0. You wrote M. Right, but I'm glad we are able to see that error. Guys, are we all okay? Is it okay so far? Everybody good? Questions? Any question? Please do share your timetables with me. All right, thank you for those timetables I'm seeing. Quite hectic, hey? But we need to find. All right, guys. Anyway, okay, guys. Let's meet again. Please, let's keep working. Don't wait for tuition to revise. Let's keep working, please. because we don't have time. And there's a whole lot that we need to do. Keep working, especially before your exam starts. We still have about a week or so. Let's push hard enough. Let's push hard enough, both maths and physics, so that when we start, we are not under pressure of trying to catch up. We're already ready. We're just playing around with questions. Please master your definitions, and all will be good. Let me say, take a picture of this question. 8 marks. Take a picture of this one. Someone sent to the group. This first, I have 2 practice questions for you. We're going to start from there. Mara, tell her what you must do. All right, I'm sure you guys got this. And take a picture of this one. There's one that I just kept. Yep. Huh? Yes, where you have to resolve the vector. Okay, please let's practice this. Very important. Already, let's see. I say, I don't know how to do this. And this is always there. I promise you. Okay, you got it, and this one. All right, guys, have a lovely evening. Give yourself some rest, but push more than resting. Okay. Good night. School. Yeah, very important. Eh? I wish I could just stay home. Honestly.